takes a second for the Elmo to warm up. We'll be right there. We're going to start on number 28 here. And we should be coming online any second. Oh, dang it. I'm not sure why it came off of that. Sorry, this takes just a second now. Take a second more, but we're about there. It ought to be popping up any second. Right now? Nope. There we go. Here we go. Imagine that you purchased a plot of land for your dream home in New Zealand in 1990 for $60,000. The land as part of New Zealand will increase in value on average of 2% per year. So this is per year. Write an exponential equation expressing the value of the land t after in t years. So you bought it for $60,000. That's your initial amount. It's going to increase 2% every year. So if you wanted, you could write it kind of like that, or you could have written it like this. Since it is just annual interest every year, it's just our simple a times b to the t equation. If the land continues to increase in value, this according to this average rate per year, will be the value of the land in 2015. So in other words, 60,000 times 1.02. How many years is it from 1990 to 2015? That's 25 years. So take your calculator. Go ahead and type in 60,000 parentheses 1.02 to the 25. And you get out 9843635. So 3596, which takes us to 340. So basically, you gain $38,436.34. How many years after 1990 will the value of the land first reach 100,000? So take 100,000, set it equal to 60,000, 1.02 to the t. I would recommend dividing by 60,000. So then, in my y equals, clear out what I have. I'm going to take 10 over 6. In my y2, I'm going to take parentheses 1.02 to the power of x. Hit graph. Okay, so there's that. Here's the other one. Doesn't even look like it's moving, but it is. Oh, it is, but we need to go further out. So I go in my window. I go to my x max. Let's go ahead and take it to 50 and see what that looks like. So there's that 10 over 6. Here's the exponential. Move in. Come up. Oh, right there. Did you see it cross? It's crossing somewhere right in here. So hit second trace. Again, push number 5. Then just hit enter, enter, and enter. And your answer is 25.796. So 25.796 years. So basically you're looking at 26 years, right? About 26 years it'll be at 100,000. Find the average rate of change of the land between 1990 and 1995. Average rate of change, slope. So look, I put on my thing from 1990 to 95. That's going to be 5 minus 0. You got to take 5 and plug it in to figure out what number goes here. You know when you plug in 0, you're going to get out 60,000. So that number goes there. Plug in the 5. You get out of here. You get 60,000. Oh, it's going to be this exact same equation, so I can just hit second enter. But I don't want 25. I only want it to be 5. So there it is. So now I'm going to write 66,244.848. Okay, minus 60,000. Enter. Divided by 5. Enter. So the average rate of change is $1,248. and it looks like 97 cents a year. So that'd be dollars per year. Okay, it's not bad. Find the average rate of change of the land between 2010 and 2015. Okay, so now I know in 2015 the value of the land was this, right? So 2015, 2010. So it's going to be 15 minus 10. Sorry, 25 minus 20. That sounds like another full class ticket. We've already done 25. It's 98,436.34. We did it right here. Minus, now I got to take 20 and plug it in. So I can come back to my calculator, hit second, enter. Now, I don't want that one, so I can hit second, enter again, second, enter, till I get back to the equation I want. Now instead of 5, I want that to be 20. Hit enter. That gives me 89,156.844. Okay, so I'm going to take 98,436.34 minus my 89,156.844, and then divide that whole thing by 5. Now it's growing at $1,855.90. So, look here. In the first 5 years, it's growing at $1,200, a little over $1,250, like $1,248, almost $1,250. But once I get further, this is going to again per year. As I let it go, it's going to get even higher per year that it's growing, because this is exponential growth. Comment on the differences between your answers for D and E. Why is this is? I just did. In E, it's going to be growing faster per year because on exponential growth, over here, it's a lot steeper than it is right here. So from 0 to 5, it wasn't as steep, but from 20 to 25, it got steeper. Okay, 29. Find the following key features of that guy. Sure. Negative, holy creep. Well, good thing it's in my calculator section. So I go to my y equals, clear out what I have, and then I'm going to type in what I see right here. Negative x cubed plus 5x squared minus 6x minus 3. Now, I'm still going to zoom 6 because I just want to see what this thing looks like in a standardized window. Okay, wow, crazy. See it coming down? It's kind of crazy. Let's find that x-intercept first. You can go to second, trace. Another name for x-intercept is a 0. If you hit enter on 0, okay, it'll ask for a left bound. So you just want to make sure you're to the left. See how my cursor is to the left of my x-intercept? It's to the left. Hit enter. Then it'll say right bound. Move your cursor so that it's to the right. See how my cursor now is to the right? Hit enter. Guess just hit enter. It'll take you right to it. So there's the 0, or the x-interval, or the x-intercept. It is negative 0.374, 0. To find the y-intercept, it's actually a lot easier. We're going to let x be 0. So under trace, just type in 0, and then hit enter. And there it is, negative 3. So 0, negative 3 is the y-intercept. Now it says, where is it increasing from? Ooh. Well, it increases from here to here. So I need to find out what those mins and maxes are. Notice they are local mins and maxes. So I can go to second, trace. I can go down to minimum, hit enter. So now I just need to be, so look again, need to be to the left of my minimum, which I am, so I hit enter. Then I move my cursor so that it is to the right Notice that it is now to the right of that minimum. Hit enter and enter. And there's the minimum value right there at 0.7847, or so said 0.785. Okay, so my minimum value is a point. Well, if I put it as a point, it'll just help me later on here. I'll show you in a minute. The really number that I care about is that negative 5.113. This right here is our local min. Okay? Now I want to find that local max. We know they're local because take a look at the graph. It goes further down past that minimum value right there. So hence it is just a local. Second trace, go down to max, hit enter. It'll say left bound. Again, we want to just be to the left of our max, which we are, so I hit enter. Now I scroll so that my cursor is to the right. See how now the cursor is to the right of that max? Hit enter and enter on guess. Take me right there. So the maximum value, I'm just going to put it again as a point because the x value is going to help me here in just a minute. 2.549, comma, negative 2.369. Again, this is the local max. So, and as I'm looking at increasing, take a look. So we just said from here to here, it's increasing. So over what x values? Well, that would be the x value of the min to the x value of the max. So my x value of the min was 0.785. X value of the max was 2.549. That means it's decreasing everywhere else. Negative infinity up to 0.785. Union with 2.549 up to infinity. Where is it positive? Ooh, so that's going to be determined by our x-intercept. Right here, notice from this x-intercept back, the graph is above the x-axis, so positive. So here's my x-intercept. So from negative infinity up to negative 0.374, it's positive. That means it's going to be negative everywhere else. So negative 0.374 to infinity. My domain, negative infinity to infinity, because I can go to the left as far as I want and to the right as far as I want. I can go up or down as far as I want too. So the range is negative infinity to infinity. Concave up. So look, concave up right here, concave down right here. The place it changes concavity is right in the middle of my min and my max. So I need to find the minimum. I need to find the middle of that min and max value of the x. So I go back to just a normal. Go back to just a normal screen. Okay. I'm going to take my x. So to find the middle of those two, I average them. So I take 2.549 plus 0.785, divide that by 2. I get 1.667. That's right in the middle. So it's concave up from negative infinity up to that point, 1.667. It's going to be concave down from 1.667 up to infinity. Take a look again at the graph. It's concave up from negative infinity up to right in the middle, that 1.66 value. Then from 1.66 value up to infinity, it's concave down. Asymptote. Again, let's look at the end behavior. As I let x come out this way to negative infinity, where's my graph going? It's going up to infinity. As I let x come out this way to infinity, where's my graph going? Well, it's going down to negative infinity. So there is no asymptote. Average rate of change, slope from negative 2 to 1, 1 minus a negative 2. Take 1 and just plug it in for x. Or come back here to your graph. Remember, go to trace, type in x is 1, hit enter. It'll tell you what the y value is there, negative 5. So this is negative 5 minus. Again, under trace, type in negative 2 and hit enter. it'll tell you what the y value is. 37. Negative 5 minus 37 is negative 42 over 1 plus 2, which is 3. Negative 42 over 3 is negative 14. There's your average rate change. That's a big problem. Let's take a look here, number 30. Okay. Jonas is practicing for a triathlon. He decides to swim, bike, and run 200 meters each. Okay, so f of x equals, it's going to have 3 parts, and we have a distance and a time. So he says he's going to swim, bike, and run 200 meters each. Jonas swims 200 meters per second at a rate of 2 meters per second. Okay, so he's going to swim 200 meters. So let's go ahead and let's just call these, like, let's go by 50s maybe. This one's going to be, yeah, that's fine. 50, 100, 150, 200. Then it's going to be 250, 3, 350, 4, 450, 5, 550, 600. He's going to go do a total of 600 meters because he's going 200 meters each. Now, this is going to be his speed. Or, yeah, did I do that wrong? Yeah, I want distance to be the y and time to be the x. Give you guys a full class ticket there. Sorry, let's get this done. Okay, so these going up should be 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, 550, 600. The time that it takes him to do it is down here. So if he swims at 2 meters per second, how long will it take him to travel 200 meters? And that'll be 100 seconds. So from 0 seconds up to 100 seconds, okay, so that means I got to go from 0 and I got to get to 100. So let's go ahead and say, let's go ahead and call these, I don't know, since that's the slowest one, let's go by 20s. 20, 40, 60, 80, 100. Then it'd be 120, 140, 160, 180, 200. Let's see if that works. So from 0 to 100, it's going to travel 200 meters. So it's going to look something like that. Okay? So that equation would look something like this. 2t. Because the y-intercept is 0 and it's traveling 2 meters per second. Okay, he then bikes 200 meters at a constant rate of 20 meters per second. So now we have a 20t. Okay, there's a problem here though, because this is going to go from 100 up to 200. So when I put in 100, I need to get right here. I need to be right here at 200. So when I put in 100, 20 times 100 is 2,000. So to get from 2,000 back down to 100 or 200, I need a minus 1,800. So this needs to be a minus 1,800. So now at 200 so how long will it take him? He says he bikes at 20 meters per second. That's only going to take him 10 seconds then. So from 100 to 110, let's go into 110. This is the equation we'll use. Think about it. If I put 100 in for 20, so I would get 20 times 100, okay, minus 1,800. I should get out 200, and I do. Now, in the next 10 seconds, so that's going to be like right to here, he's going to go another 200 meters. He's and be to there. That thing, look how steep that is. So we're trying to find the equation of that line, which I think I did right here. Let's check it and see. If I put in 20 times 110 minus 1800, I hopefully get out 400. And I do. Got out 400. So all I did is I said I know I wanted 20t. I put in 100. That gave me 2,000. But I wanted it to actually be at 200, not 2,000. So I subtracted 1,800 to get to the 200. We're there. Last one. Says that he's going to run. And he runs at a rate of 5 meters per second. Okay? 5 meters per second. That's going to be from 110 seconds up to, think about it, if he's running 5 meters per second, how long does it take him to run 200 meters? It takes him 40 seconds. So it'll be up to 150, because 110 plus 40 is 150. Okay? 150. So, looking at that, if I plug in 110, 5 times 110, I'm going to have to minus something to get out 400. So let's take 5 times 110. That gives me 550 minus what is 400? Minus 150. Gives me 400. Let's see if it works for the last one. 5 times 150 minus 150 we hope equals 600. That's what we're hoping. So I take 5 times 150 minus 150. That equals 600. So there's our equation. So we need to minus 150 here. There's our equation. Now take a look. So from 110, which is right here, to 150, it's going to be right here, equals another 200 meters. Not quite as steep as that one. Woo! That's crazy. That's crazy. All right, let's do these last two and be done. Use your calculator to graph the following piecewise functions. We don't actually need a calculator to do that. We can do it our own. We have x, we have y, 2x, from x is less than negative 3. Negative 3, negative 4, negative 5. 2 times negative 3, negative 6, plus 9 is 3. 2 times negative 4, negative 8, plus 9 is 1. 2 times negative 5, negative 10, plus 9 is negative 1. So at negative 3, I'm at 3. Is it open or closed? It's open. Then at negative 4, I'm at 1. Negative 5, I'm at negative. Okay, so now this is going like this. And that would be x is less than negative 3. Now from negative 3 to 2, it's this. So do another one. From negative 3 to 2. Negative 3 squared is 9. 9 minus 6 is 3. So that's going to be solid because it's equal to. If I plug in a 2, 2 squared is 4 minus 6. Negative 2, that's open because it's not equal to. See the line? No line. Closed circle, open circle. So at 2, negative 2, open circle. At negative 3, 3, closed circle. This is a parabola. So it must be looking something like, and it does have a x-intercept. If I plug in 0 here, I get negative 6. So it has a y-intercept of negative 6. So it looks something like that. Now let's go ahead and do this last guy. Bigger than 2. 2, 3, 4. If I plug in 2, 2 over 2 is 1. 3 over 2, 3 over 2, or 1.5. 4 over 2, 2. So at 2, I'm at 1. At 3, I'm at 1.5. And at 4, I'm at 2. Okay. It's going like that. So put your pencil on it. Discontinuous. Not continuous. It's discontinuous. Next one, here we go. From negative 6 to negative 3. So if I plug in negative 6, I get 2 to the 0, which is 1. 2 to the 1 is, 2 to the 0, which is 1. 1 minus 3 is negative 2. If I plug in negative 3, negative 3 plus 6 is 3. 2 to the third is 8. 8 minus 3 is 5. So negative 6, I'm at negative 2. open circle because not equal to. At negative 3, 5, it's going to be closed because it is equal to. And it's kind of curvy like exponential growth because it is exponential growth. From negative 3 to negative 1, it's 1. Oh, from negative 3, it's negative 1, it's 1. Open circle on both. Okay? Because it's not equal to either negative 3 nor negative 1. So from negative 1 to 4, it's this guy. Let's make our little T chart. Negative 1 to 4. Negative 1 plus 1 is 0. Squared is 0. Negate 0 plus 1 is 1. 4 plus 1 is 5. 5 squared is 25. Negate negative 25 plus 1 is negative 24. So at negative 1, it's at 1. Filled in because it is equal to. And at 4, I'm at negative 24, which is way down here somewhere. And it is quadratic, so it's going to look probably something. It either looks like that or it opening down, so it probably doesn't look like this. It probably actually let's find the y-intercept. Help us out. 0 plus 1 is 1. 1 squared is 1. Negative 1 plus 1 is 0. So, it goes through 0. Okay. It's actually looking more like that. All right. Is it continuous? Nope. Hey, folks, that's it. Good luck on your test, and we will see you later. Have a great day.